Lesson 12.3, you will find experimental and theoretical probabilities and use them to make predictions. Theoretical probability is what you expect to happen. It's the number of favorable outcomes over the total possible outcomes. For example, when you roll a number cube, you expect that you're going to roll the number 3 1/6 of the time because there's 1 3 on the cube. There's 1 3, that's your favorable outcomes, over 6 total possible outcomes. Experimental probability is what actually happens when you conduct an experiment. So like if you rolled that number cube 100 times and you rolled a 3 20 times, the experimental probability would be 20 out of 100, or 1/5. What is the theoretical probability of rolling a double 1 using 2 number cubes? Well, there's only one way to get a double 1. That's rolling a 1 and a 1. So there's one favorable outcome. And there are 36 total possible ways. If you listed out all the possible outcomes, there would be 36 of them. So rolling a double 1 using number cubes would be 1/36 for the theoretical probability. Number 2 says the graph shows the results of an experiment in which 2 number cubes were rolled. According to the experimental probability, is the sum of 12 likely to occur? Well, the number 12 showed up one time out of a lot of rolls. So it was not very likely. Referring to the graph above, according to the experimental probability, which sum is most likely to occur? Well, the one that's most likely is this one right here because it happened the most often. So a sum of 8 is most likely to occur. In the next example, it says 300 people were surveyed as to how they keep track of time. What's the experimental probability that a person uses his or her cell phone? Well, 185 people use their cell phone. Now we need to figure out of how many total people were surveyed. So if you go and add all these together, you end up with 300. So the experimental probability is 185 out of 300, and that can be simplified to being 37/60ths. It can be written that way as a fraction, or sometimes you will see probabilities shown as a decimal. So you could take 37 and divide it by 60. 37 divided by 60, and that ends up being about 0.616, and then that 6 repeats. And that would also be shown as a percent of 61.6 repeating percent. So the probability is either 37/60ths or 0.6 about, or 61.6 repeating percent. What is the experimental probability that a person uses his or her watch to keep track of time? Well, 57 people used a watch. 57 people out of 300 total. 57 over 300 can be simplified by dividing both the numerator and denominator by 3, and you end up with 19/100ths. So the experimental probability is 19/100ths, or as a decimal, that's 19 divided by 100, which is 0.19. or as a percent, move it the decimal point 2 places to the right, and you get 19%. Now we're going to use probabilities to make predictions. It says, at a plant that manufactures light bulbs, an inspector finds that the probability that a light bulb is not defective is 8/11. Is this probability experimental or theoretical? Well, this would be experimental because they actually checked it out and did it. So it's experimental. They found that 8 out of 11 were not defective. Now, if the company wants to have 10,000 non-defective light bulbs, how many light bulbs will they need to make? Well, 8 are not defective out of 11 total light bulbs, and we want to know how many total we would have to make. So we're going to have X down here for our total to have 10,000 non-defective light bulbs. Now you're going to solve your proportion like we've been doing all year. 8x is equal to 10,000 times 11, which is 110,000. Now divide both sides by 8. X equals 13,750 light bulbs is how many they would have to make to end up with 10,000 that are non-defective. In a recent survey of 150 people, 18 responded that they were left-handed. If an additional 2,500 people are surveyed, how many would be expected to be left-handed? Well, 18 were left-handed out of 150 total people. So we want to know if we surveyed another 2,500 people, how many of those would be expected to be left-handed? So we'd put X on the top this time because that stands for the left-handed people out of 2,500 total people. Now go ahead and solve the proportion. 150 times X is 150X equals 18 times 2,500, which is 45,000. And then divide both sides by 150. And you end up with X equals 300. You'd expect 300 people would be left-handed out of the 2,500 additional people that were surveyed.